Hi, let's talk about another gas law, Gay Lussac. Here it is, P1 divided by T1 equals P2 divided by T2. So a couple of pieces of information on this. Again, one of the most important things for gases, remember temperature has to be in Kelvin. And here's a reminder, Kelvin is 273.15 plus your Celsius. Pressure can be in any unit, but the unit has to be the same for the initial and final conditions for both the P1 and the P2. So you could have it in ATM, millimeters of mercury, torr, that's all fine. But the pressure has to be ATM and ATM. They have to be the same. This is a direct relationship, directly proportional. So as pressure increases, so does the temperature. So if I increase the pressure, there's all of these collisions happening in the gas molecules on the side of the container, the temperature is also going to increase. Likewise, equally true, if you decrease the pressure, you're going to decrease the temperature. Be really careful solving for temperature in the denominator. I've seen students make this mistake often where they will solve and come up with a P1 T2 equals T1. Oh, excuse me. This is what they come up with. P1 divided by T1 P2. So see what they did? They just divided both sides by P2, but here's a mistake. They say that equals T2. That doesn't equal T2. T2 is still in the denominator, 1 over T2. So just be really careful solving for temperature. You could just reciprocate both of those and get T2 equals T1 times P2 divided by P1. Just flip both of them. So be careful. I see students make that mistake often. Lastly, for Gay Lussac's gas law, the volume is held constant. So volume is going to be constant, a fixed container. Now I do have an example for you. We have an initial pressure of 1 atm. The temperature is 25 degrees C. So that right there would be considered standard temperature and pressure for gases. We're going to double the pressure, okay? Double the pressure to 2 atm. And the question is, what's the temperature? Well, let's make a prediction. We know that this is directly related. So if I increase the pressure, you would predict what's going to happen to the temperature. It's also going to increase. And I know some of you just thought this. You knew exactly how much it would increase. It's going to double. If the pressure doubles, the temperature is also going to double. We'll see it, we'll prove it for you. Now, notice I'm following these very classic steps. I labeled everything that was given to me, then I identified the formula that I'm going to use. Well, I have initial and final conditions for pressure and temperature, so it means we're going to use the Gay Lussac law. Next, we're going to solve for our unknown, and I was very purposeful. I chose T2 so that we could practice solving for something that's in the denominator. So I've got P1 over T1 equals P2 over T2. Okay, this is how I do it. I'm first going to get the T2 in the numerator. So I'm going to multiply both sides by T2. So T2 cancels over there, and I'd have T2 P1 over T1 equals P2. Now I want to solve and get the T2 by itself. So we multiply both sides by T1 over P1. T1 over P1. So the pressure and the temperature cancels, and we will get T2 equals P2 T1 right here divided by P1. Okay, so we solved. I'm going to erase all this. I know that looks like a lot. So let's erase that. You got to see it. I'll rewrite this up here so it's nice and clean. P2 T1 divided by P1. Now plug and chug, meaning I'm going to plug the numbers in for the variables and then just put it in my calculator. Always include your units. The units will confirm if you did it correctly. So we will have T2 equals the P2, 2 atm, times, let's pause a second, temperature. Temperature has to be in Kelvin. So let's go plus 273.15. That is going to give us a temperature of 298.15 Kelvin. You may or may not have to include the 0.15. It just depends on your class. Ask your teacher, your professor. Err on the side of doing more if you don't know and include the 0.15. Okay, so that initial temperature, 298.15 Kelvin, divided by the pressure, which was 1 atm. So T2 is going to equal 596.30. Oh, look at units. Atm cancels and we are left with Kelvin. So it did double. Check it out. The pressure doubled and the temperature went from 298 to 596. Directly related. Pretty cool. Pretty cool. So there you have another gas law. If you haven't seen the other videos, check out Charles' Law, Boyle's Law, and the Combined Gas Law. And if you're moving on from there, the Ideal Gas Law is going to be your next video. All right, you're doing good. Keep working hard. It will make a difference. Thanks.